Okay, so the first, the second topic that we had is the maritime navigation, wherein this is after the lesson one, which is the land transportation. Lesson two is maritime navigation. So, so I have here. Okay, so this is here. We have now the figure one, wherein figure one focuses on figure one shows MV Astoria, formerly Stockholm in 2016 as a cruise ship. Much of her original form remains, including her shear. Figure 2's Typhoon class submarines are the largest submarines ever built. So figure 3 is US Navy aircraft, and we have here the self-propelled barges uh, on the Grand Canal of China in figure 4. So all of those figure 1 to figure 4 are are vessels that we use to navigate rivers, seas, oceans, to lead us from point to point, especially like here in our country. So, overview, maritime navigation is the field of study that focuses on controlling and mobilizing aircraft in the water. Navigators needed to master the skill on how to locate position through patterns. Today, radars and sonar devices help captains of the ship to navigate through rough seas days and nights. Ships are the primary mode of transportation for inter-island travel in the Philippines and other archipelagos through the world. Ships are built according to their purpose. Today, we have passenger vessels, barges, submarines, and even aircraft carriers in the Navy. So, science behind marine navigation. So number one is 2.1 is fluid. So the behavior of fluid is of the great currents interested both pure science and in industry. So fluid is anything that flows. We use the term for both liquids and gas. Statics is the study of fluids at rest, and fluid dynamics is the study of fluids in motion. Okay, so you have there the term fluid, so anything that flows. So we grew up knowing that that's how we label liquids and gas, fluid. Of a substance is mass m. So mass m. So you have here the mass m per unit volume. So per unit volume v. So in equation we have the density or the rho equals to m over v, where the m is the mass and v is the volume. So the typical unit of density is kilogram per cubic meter. So, again, you read it as kilogram per cubic meter. Pero pag ito naman, grams per cubic centimeter. So, don't forget the unit if you're solving for the density. So, for table 1, you have here the densities of some common materials. So, like example, you have the water. Water is naka-constant to siya. So, this is constant. Ayan, constant. I'm gonna erase that. So, that's constant tayo dito. Ito constant to siya, which is at 1,000 kilogram per cubic meter and 1.00 per gram per cubic meter. So you have here from water, you have here down to brass, copper, glass, gold, ice. So yan, iron, lead, mercury, benzene, gasoline. Okay? So there you have it. Now, specific gravity. After knowing the density, we will now go for the specific gravity. So water is the basis for comparing the densities of solid and liquid substances. The ratio of the density of a substance 2, the density of the water at 4 Celsius is called its specific gravity or relative density. So, specific gravity is equal to density of the substance over density of the water. So, you just have to compute first for the density of the substance, and then you go for the density of the specific gravity. So, it has no unit. So, example, we have here. So you have there the mass of a 100 cubic centimeter flask is 23 grams. When empty, and 97.84 grams when full of oil. So we will compute for the density of the oil and the specific gravity of the oil. So given, you have here the given. So andito ang given natin. Given, mass of the empty flask is equal to 23. Empty, ibig sabihin wala pa siyang laman. Meron ang weight niya is 23 grams. Mass of the flask with oil. So with oil na siya, meron na siyang 23 at 97.84 gram yan siya. So volume of oil will be having 100 cubic centimeter. Now to solve this one, density of the oil is equals to, so density of the oil, we will use the formula rho is equals to mass over volume equals, so 97.84 gram minus 23. Ito yung may laman, so ito may laman to siya, ito ang empty kanina. So babawasan lang natin, divided by 100 cubic centimeter is equals to 0.748 gram per cubic centimeter. So dahil na-solve mo na to, gagamitin mo siya ngayon to solve the specific gravity of the oil. So to solve for the specific gravity of the oil, you have density of the oil over density of the water. So you have 0.748 gram per cubic centimeter over 1 gram. So this one here is, ito na yung sasabi ko na constant. Ayan. Ang hirap pag walang. Ayan. So, constant yan siya. Ang hirap pag mouse lang. Ayan. So, this is a constant. Okay? Constant ang gram na, itong sa baba. Hindi na yung magbabago. Always yan siya. Always siyang i-measure the density, the gravity kasi always siyang i-measure against the water. So, you have now 0.48. It has no unit. So, nawawala. So, technically, this one is cancelled out and this one is cancelled out. Kaya wala na siyang unit. Okay? Now, we have here this one. Mass of the empty flask, 30 gram. Mass of the flask with liquid is 110 grams. Volume of liquid is 100 cubic centimeter. Now, find the density of the liquid and the specific gravity of the liquid. So with this, the density of the liquid. So the density of liquid is, we will use this formula. So the formula of rho is equals to mass over volume. So equals to 110 minus 30 over 100 cubic centimeter. So it will give us 80 gram per cubic centimeter. So specific gravity of the liquid. On the other hand, we will use the density of the liquid over density of the water. So 0.80 gram per cubic centimeter over 1 gram per cubic centimeter. And that will give us 0.80. Now, kung mapapansin nyo, parang it will always be the same, pero uh, walang kanyang unit because our unit has been cancelled out. Kaya, no, it is no unit. Okay? So, there you have it. Now, another example. We have mass of empty flask. We have uh, here 40 gram and then 144 with liquid and volume of liquid 100 cubic centimeter. So find the density of the liquid and specific gravity of the liquid. So density of the liquid, we have this one we follow, okay, and then we just subtract 140 with liquid and with empty, 140 minus 40 over 100 cubic centimeter. That will give you 1.0 gram per cubic centimeter. Now the specific gravity of the liquid, it is density of the liquid. So density of the liquid, ito yung density of the liquid mo, and over water. So maka-cancel out to. So 1 over 1, that will give you 1.0. Okay? So for I will ask you sana dapat to answer this one, but um Yan. So, this is just another. So, for example purposes na lang to. Ayan. So, so 85 with liquid minus 20, subtract to 25 over 50 volume of the liquid. Okay, klaro naman siya. Mass, you have the mass here and the volume here. Okay, so 120, 1.20 grams per cubic centimeter. So density of the liquid, ibaba, ito siya, ito na yung density of the liquid natin. So, moreover, it will be 120, 120, so 120 siya, 120 there, 1.20, 1.20 over 1 gram. So, sabi nga natin, this will be cancel out. So, magiging sagot mo lang dyan is 1.20. Okay. So, another one. We have here, empty of 28, pag may laman 88, 50 ang kanyang liquid or ang kanyang volume. So, following the same example, the same procedure, and you will 1.20 gram din siya per cubic meter. At yun din ang magiging density of the liquid natin over the density of water. Again, constant ang 1 gram per cubic centimeter, and that will give us 1.20. Okay. Another. Okay. Okay. So as you can see, 150 minus 50 over 100, that will give you 1.00 gram per cubic centimeter. Yun din ang magiging density of liquid natin all over density of water, and that will give you 1.00. Okay? So, I hope you got how we did compute um, the density. Now we have here the pressure. Pressure is equal to the force per unit area. So a force is applied to a perpendicular area. In equation, pressure is equal to force over area. So we have this formula here, okay? So the unit pressure is Pascal. So ibig sabihin, pag makompute mo na, ang unit mo lagi is Pascal or PA here. Named after French Blaise Pascal. So, a Pascal is 1 Pascal equals to Newton over meter squared. Again, Newton per meter squared. So, ibig sabihin the force and the area. Okay? So, example, the 20 Newton force is applied in a 2 meter squared surface area of the block. Calculate the pressure experience of the block. So, answer you have here, F over A. So, ang F mo is, kasi nandun ako, 20 and force. So, that's 20. Applied in a surface. So, you have now here the 2 meter squared surface. So, yun yung area. Yung surface area. So, 20 over 10, that will give you 10. So, N over M squared, that will give you, that will result to Pascal. So, 10 Pascal. Another example you have here. So 15n over 3 meters squared. So a wooden block is placed on a table with surface area of 3 meters squared. So nandun yung surface area with 3 meters squared. So yan yung automatic ng area mo. Kasi may nandito yung word na surface area. If a force, nandun na, if a force of 15N is applied to the block, what pressure does the block exert on the table? So, we have 5 pascals. Yan. Same with our example number 2 and example number 3 here. So, we have force of. Nandun yung term na force of. So, technically, this will be now your force. Yan. This is your force. to a steel beam with a surface area. So dahil eto na yung nandun word na surface area, this is now your surface area. Ayan, SA. Determine the pressure of beam. So 120 divided by 4 is 30. So you just have to divide. Now, our turn, we have here example, but kung nagklase talaga tayo, you will solve for this one. So you just have here, doon na yung force applied over the meter area, the surface area. So, following the formula, that will give you 5 passes. Ayan. Another. So, doon ang given natin, force applied, 100 and surface area natin, 2 meters squared. Ayan. So, 50 p. Okay. So, The next also concept in maritime navigation, aside from the density, pressure, we have the idea of buoyancy. So, buoyancy is when a body is immersed in a liquid, the fluid will exert upward of the body equal to the weight of the fluid that is displaced on the body. So, in figure 6, as you have seen, shown a body fully submerged in a fluid and experience a buoyancy force. Buoyancy force is a force applied by the liquid fluid on an object submerged in it. A buoyant force is applied only on a surface submerged in the fluid. The bigger the surface area contacted by the fluid, the bigger the buoyant force will have exerted by the fluid into the body. When the weight is bigger than the buoyant force, the body will sink. Okay? If the weight is bigger. When the weight is much lesser than the body will float. When the weight is less than or equal to the buoyant force, the vice versa, the body will partially emerge. So, pag mas malaki ang weight ng katawan, so lulubog ang katawan. Pero than the buoyancy force. So, sabi nga nila, yung buoyancy force parang, just imagine, parang tayo na daw, our lungs is full of air. So, technically, hindi talaga tayo malulunod. But, unless mapupuno ng water yung body natin. Pero pag hindi siya mapuno, lulutang lang tayo. Kaya ang iba, ang nangyayari nga, di ba, is, kahit nagpo-float tayo sa water because our body has its own buoyancy. So, note the following formula. For density, we have the rho equals to mass over volume. For volume, mass over density, gauge pressure, P pressure minus the pascals equals to PGH, pressure equals to P over force over area. So, common question, both a nail, smaller size, and ship, bigger in size, are made from steel. So, why the ship will float and the nail will sink? So dahil the answer here is because of the buoyancy. So the curve at the bottom of the ship holds the key to answer this question. The surface area contacted by the fluid is big. So yung surface area, which means the fluid will also exert a bigger buoyancy force to the ship. So dahil malaki na siya, nagkakaroon force ang water, pati ang weight. Ayan. Ang nail naman kasi has limited surface area where the fluid can exert an upward force. So that's why lulubog talaga ang ating um, yun, ang ating nail. So buoyancy application usually and widely used in maritime search and rescue in the water and naval warfare. The most common technology build which uses this concept is the submarine. Okay, so that's it. So thank you. If you have questions, you may just post it on our Google Classroom below on the video that I will be posting, which is this one. Okay, so thank you for watching, and I just do review if for this topic.